Okay, I just wanted to take a few minutes to do a walkthrough on this lab that we're doing online. Normally we would do this activity in the classroom, and there are these three reactions that we would work through. We would do it in a coffee cup calorimeter, just like the questions that you've been looking at. And you would gather data for each one of these reactions by, in the first one, putting 4 grams of solid NaOH in water. That would cause the NaOH to dissolve, and you would do the calorimetry experiment and then calculate out what H would be. So you'd get an experimental value of H, call that experimental 1. Then there would be another reaction where we take the dissolved NaOH and we put it in a 1 mole per liter solution of hydrochloric acid. And I see, down here, NaOH plus HCl. And then we get a second enthalpy, which we would call an experimental enthalpy, number 2. And then last, you would do some NaOH and HCl, and you would mix those two together and come up with a third experimental value, experiment 3. Okay, so all those experiments, you're going to carry them out by looking at the simulation. So let me just open that up. Oh, didn't want to open today. There we go. So you're going to go to experiment and run experiment, and then you're going to run through the different experiments just as I was showing you there. So you go into the first one here and you pick what you want to load into the experiment. I'm going to choose a solid. I look at the menu. I'm going to choose sodium hydroxide. I can put down how many grams of sodium hydroxide I want. Let me just flip back to see how many it was supposed to be. It's supposed to be 4 grams in 100 mils of water. So we'll go back to the screen there. So we'll put in 4 grams, and it's automatically set at a room temperature 20 degrees. When that first beaker is set up, we say next. Now we're going to set up the second beaker here that's in the calorimeter. So this time we are just looking to do a liquid. So it says we want to get water. So we'll click on water. We want 100 mils or 100 grams of water. Its initial temperature is 20. And the specific heat is 4.184. Okay, and then when that's set up, we're ready to take the mass of NaOH, put it into the water, and see what the enthalpy change is, see what the temperature change will be in the calorimeter, and we can calculate experimentally the enthalpy change. So I'm just going to turn on a graph so we can see what's going on and hit start. And so it loaded the NaOH into the calorimeter. And as it's stirring it and it's dissolving, we can see there's an enthalpy change. It's exothermic. It's getting warmer, and eventually that will reach a maximum. That's what the graph is showing. And when that maximum is reached, the calorimeter stops. Okay, and so there's your data. We started at 20, so that was the initial temperature, and there's our final temperature for this first reaction, 30.23. So if I went back to the lab, reaction number 1, I'd go down to these tables. Oops, sorry, next screen. Go down to these tables. There's reaction number 1. We put in 4 grams of sodium hydroxide. Its initial temperature was 20 degrees Celsius. We put in 100 grams of water, and its initial temperature was 20 degrees Celsius, and the final temperature, my memory's forgotten already, 30.23. 30.23 degrees Celsius. So now you can calculate the delta H for this using that data, and you're going to go through the other 2 reactions in the same way. You're going to reset the calorimeter, and then you're going to set it up with solid and 1 mole per liter HCl, and then 2 solutions, 1 of 2 molar HCl and 1 of 2 mole per liter NaOH. And each time you're going to get an initial temperature and a final temperature, and you'll be able to calculate out experimentally all enthalpy reactions for all three of these. Okay, so that's the first step. Once you've gone through each of these and got an experimental, down in the calculations, I want you to show that Hess's law actually works. So if you try and figure out reaction 2, I know you have an experimental value for it, but you can get we'll call it a theoretical value. In theory, we can get reaction 2 by adding reaction 1 and reaction 3 together. So if you go back to Hess's law, you can take this reaction and that reaction, add them together, and you'll end up with this as your target reaction. So in the calculation section, I know you already got an enthalpy here from the calorimetry data. I want you to calculate this number again, and this time use Hess's law. Okay? And so you're going to just add this and this together. You've got the enthalpy numbers for reactions 1 and 3. I want you to add these two equations together to get this reaction number 2. And then whatever you did to those two equations to add them, do the same thing to the enthalpies and add those together. So that for the second equation, you're going to have an experimental number and you're going to have a theory number. Theory number being the one done by Hess's law. Okay, so you're going to have a Hess's law number as well as an experimental number that we're going to find by calorimetry. So for reaction number 2, you're going to get the enthalpy twice. And then our job is, in the final part of the calculations, is to just do a comparison of the calorimetry number, we'll call that the experimental number, with the theoretical number that you calculated. And I want you to get a percent difference and just talk about what might have caused any discrepancy. So if you remember, percent difference would be equal to take the absolute value of the calculated value minus the theoretical value divided by the theory value times 100%. And then you'll see how far off these two numbers were. In a perfect world, and I don't know if this simulator is the perfect world or not, this would be a difference of 0. But I think there's going to be some differences there, and you can probably explain using some ideas of experimental error what might cause the differences. But in theory, experiment 1, so delta H2, or the enthalpy for experiment 2, should be equal to delta H1 plus delta H3. And we'll see if that's true when you do your percent difference. Okay? So hopefully that helps. I don't think there's much more I can show you on here. When you're done your first reaction, of course, you just hit reset, and then you go through the process again. Click on what it is you want, the solids or solutions, for instance. Choose a solution. So hydrochloric acid, set its volume, set its molarity or its molar concentration. I think it was 2. And then as you move to the next one, you hit next. That gives you the next one to set up. You hit next. That lets you run the experiment. Okay? So that's the deal with the lab this week. See how you can do with that. We'll do the same kind of thing. You're going to just fill in the data. So I gave you the tables that you can actually use to fill in the data. So fill in those tables, trying to maintain significant digits and precision, things like that. And then work through these calculations. So you're going to do an enthalpy change for each of the 3 reactions using your data. Then you're going to show that you can add 1 and 3 together to get 2 and calculate out a new enthalpy for it. And then just do a comparison. Okay, the stuff you did last week on the peanut is looking pretty good. All the calculations are great. I've just got a few more to finish up, and then I'll send those back to you. Okay, anyway, unless there's other questions, I will comment back on this if there are some questions, and we'll go from there.